Someone has already tried to repair this outdoor PCB. Look here, some work has been done, and you can see soldering marks in this area. Apart from that, there is also some soldering done inside here, which means this PCB was blasted before. All the PCB tracks in this area have been damaged and blown away. So before repairing a PCB like this, the first thing we need to do is remove all the burnt or blasted components and identify which parts are faulty. But it looks like someone has already worked on it quite a lot. Still, it is very important to check it once again properly. So what we will do is remove all these components once and then work on this area again to make sure no PCB track is missed. We will repair all the tracks properly. First, we will remove this component from here because the area underneath it is blasted. Then we will check if there's any other hidden damage underneath. Now look, I have completely removed this connector. Now look here, someone has connected a wire to it. You can see they have done some soldering and added a wire, but I think it has been done incorrectly. It has not been soldered properly. So I will remove these parts from here. All of these components here are ZNRs, so I will remove the ZNRs. I think one of the ZNRs may be burnt, or maybe it has blasted internally. Let's remove this ZNR from here. It looks like this one is blasted. Look, this one seems a little better, but we will still check it. So this is the earthing wire, and it has been blasted. A very high voltage spike came here, and that is why this happened. Now we'll clean this section properly. Now we have removed these ZNRs from here, so we will check them to see whether they are faulty or okay, because this one looked damaged to me. So let's check the one that looked faulty. We will check it in resistance mode. Look, when I connect one probe here and the other probe to the second leg, it is showing direct resistance. It is showing 3.168 kiloohms, which means this ZNR has become short-circuited. Now let's check the second ZNR. When I connect the probes to this one, look, it is not showing any resistance value here. This means there is a chance that this one may be okay. Sometimes, even if a ZNR looks okay when checked with a multimeter, it can still cause the breaker to trip in some cases. But right now, this one looks fine to me. So we will install this ZNR back in its place. So, I will install a new ZNR here. This capacitor should also be checked in continuity mode to make sure it is not short-circuited. Now, as there was a problem on its high side, someone has also worked on its IPM here. Look here. This is its IGBT, and this is the bridge rectifier. I will also check these to see if there is any issue in them. In this kind of situation, I have tested the high side in many of my videos, so I will check it in this video too, but I will only tell you whether it is okay or not, because explaining the same work every time is not a good thing. So I will only tell you whether it is okay or faulty. So this is V, and this is W, and these are almost okay. After this, let's check its diode and IGBT. So this is its IGBT. Let's check it. I think someone may have changed it as well. Now look, its IGBT is showing 0 value, so this IGBT is totally short-circuited. Now we will also check the diode. As you know, the outside pins of this diode are common, and the center one is the cathode. So I will check it. Look, when I place the probes on these 2 points, it should be 0, and it is 0. Then keeping the probe on this point, and checking the center point, it is showing 0.378 value. So this is also okay. I will remove this IGBT from here. After removing the IGBT from here, now we will check this area. To drive the gate of the IGBT, there is a protection resistor installed here. Its value is 47R0, meaning it is a 47 ohm resistor, and this is R453. We will check its value. So this value is showing something different. Look, it is showing 112 kiloohms, so it will not drive the gate. That is why this resistor has become faulty. Similarly, there is a pull-down resistor connected to its gate. This resistor is 10 kiloohms, so let's check this as well to see if it is damaged or not. It is showing exactly 10 kiloohms, so this one is okay. There is no fault in it. There is also a 10 milliohm 5-watt shunt resistor installed here. We will check this too. Yes, this is okay. There is no fault in it. Let's check the resistor outside the circuit to confirm whether it is actually faulty or not. Look, it has gone to almost 274 kiloohms, so its value has become very high. That is why we have removed it. Now, let's check its value again to see whether it is actually okay now or not. Let's check it. Look, now it is showing 47.1 ohms, so now this work is okay. Now I will install this IGBT in it, G40N60 UFD. I have told you in many videos that whenever you need to change the IGBT, diode, bridge rectifier, or IPM, change them after installing the heatsink, because this makes their alignment proper. Then the work becomes easier, and the air gap underneath them is also removed. Now we will do the final testing of this microcontroller to see whether this microcontroller is okay or not. If this is also short-circuited, then there will still be a problem. For this, we have to check on pin number 8 and 10. Power supply comes here, VCC and ground, and as you can see, it is connected with capacitor number 38. So we will check here. We have to do 2 types of tests here. I have already told you in a previous video that we can check it in both continuity mode and diode mode, but right now we will first check it in continuity mode. So this is capacitor number 38. Look, it is showing a value of 320.5 ohms. Similarly, if we take it to diode mode, look, it is showing 0.321 voltage drop. So this means it is okay. Now we can give it power and check it. Similarly, we also need to check the other side of the microcontroller. So here you can see that pins number 42 and 44 have VCC and ground. At this time, pins 41 and 42 are connected together, and pins 43 and 44 are connected together. As you can see here, capacitors C11 and C36 are connected in parallel. and the supply is coming across them, so we will check this point once as well and confirm it. So, as soon as I connected it here, you can see it is showing a 0.321 voltage drop. This means that even in continuity mode, it is showing a value of 320.6 ohms. So yes, this is okay. Now look here. I was about to make one major mistake. I had checked this, and then I installed the heatsink in front of you, but I did not install the protective sheet or cover on top of these components. So this was a very big mistake. What would have happened is that both of these components, especially the IGBT, would have shorted immediately. That is why installing this protective sheet on top of them is very important. If you try to run the PCB without it, these components can get damaged instantly. We will apply a small amount of this so that our covers sit properly on top of it and do not move. After that, we will pack it properly. Now, I will connect power to it, and its LED 2 has turned on. LED 1 has also turned on, and the switching has also started. You can see here, this is LED 1, and it is also on now. This means the PCB has powered on properly. Now we will check the voltage on the IPM. So we will connect the probe here, one on negative and one on positive. Here we are getting 298 volts DC on the positive side. Now let's check the U, V, and W outputs. This is not okay. On this one, we are getting 13.76 volts. Similarly, we will check the second one, on V. Look, there is no proper voltage here. Now let's check the next one. Here, voltage is present, around 13 something volts. But on its V phase, let me check once again. So yes, this IPM is also shorted. It is only showing around 361 millivolts on the V phase. You can see that the V phase is shorted. No, the voltage is coming. Yes, the voltage is present. I thought there was an issue with that point, but the voltage is actually coming. When I checked from another point, it was okay. And now it has turned on. It has started working at 16 degrees Celsius, and the outside temperature is 33 degrees Celsius. The outdoor circuit has powered on, and the indoor fan motor has started running. You can see that its communication with the indoor unit is working properly. In the indoor circuit, this LED is installed, and when it blinks, we can understand that communication is happening in the system. Now, we will wait for a little while. And now, the compressor has started. It has started picking up speed. And its circuit is also completely okay and behaving normally. So you can see, the speed is slowly increasing. It has become completely okay now.
Click on the left or right thumbnail to watch our next videos, and subscribe. Thank you.